One of the most underutilized tools in the math classroom is the number line. It is typically displayed right above your smartboard. So the number line is certainly visible, though rarely used as effectively as it might be. We know that mathematical models are instrumental in helping children develop structures or ways of seeing mathematical concepts. Today, we're going to focus on using a life-size model of an open number line, and you will see just how powerful this tool is as we help students develop the number sense. Did you know that students are more cognitively active when using an open number line than when using other models? Base 10 blocks, for example, rely on visualization of stationary groups of objects. Both hundreds tables and base 10 blocks are grouped by tens, and that structure has an important role in mathematics, but the open number line does a better job of suggesting the continuity and the linearity that helps students to develop greater flexibility with numbers. So we're going to start off with doing a little introduction to the open number line. So I want you to think about this top number line and think about the magnitude of this number line. And now compare it to the magnitude of the second number line. Notice that once I place that second number, it requires a different set of intervals, and our brains are thinking different things. I know for me, I was thinking fractions and decimals when I looked at this number line. This one I was thinking skip counting by tens, 10, 20, 30, benchmarks of 50. It made me think completely different things. So I want you to think about your grade level as we go through these activities and think about your specific students. You'll want to make decisions about which activities fit with your students' needs and which can be modified to fit their needs.
Task 2 is called hiding numbers. You are going to place the cards 0 to 10 on the number line. Notice that I have one of the cards hidden by placing a blank card on top of the number. You're going to ask your students which number is hiding. Give them some think time, call in a volunteer, and ask them how they know. You can increase the rigor of this task by hiding maybe 2 numbers. If you really want to bump up the rigor, hide 3. The third task we're going to talk about today, let me get rid of these. The third task is called the dot and number match. You're going to display all the numbers from 0 to 10 on the number line. You show the students a dot card. Have them picture in their minds which number on the number line it would match. Call up a volunteer to place the dot card over the number it is equal to. Task 4 is called Where Does It Go? You're going to begin with a cleared number line. You're going to ask the students, where should 0 go? We might be tempted to insist that it go to the far left, but it's important that we acknowledge that 0 can go anywhere on the number line as we begin thinking about number sense. Our next question to the students would be, where should 10 go? Again, it can go anywhere on the number line as long as it's to the right of 0. But once I place that second endpoint, the number line is a closed number line and it's no longer flexible. This might pose a problem of space to do the activity. So after we have the discussion about the placement and we talk that this is okay, we now want to encourage the students to spread out those endpoints so that we can do our activity today. My next question, once we have the endpoints spread out, would be, where should I place the 5? Have the students visualize the placement, and then ask them, how do they know? Once we have the 5 in the correct location, we're going to move the endpoint of 10 over. And we're going to ask again, where should 5 go? Is it in the correct location? And how do you know? And we're going to adjust our midway benchmark as we go. For intermediate level teachers, think about how this activity could be modified to use number lines that do not begin at 0, or number lines that have a larger number set, or they have decimal values or even fractions.
This task is going to be called next to far away. So you'll notice I have first displayed on the number line the number 20 and the number 100. I'm then going to give some randomly selected numbers to students and ask them where do they believe these should go on the number line, thinking about the interval of the number line. So we'll imagine that we have students who discuss it with each other, maybe have a partner, and then they come up and they place it. After quite a bit of a discussion, and we get them in the place that we like, then we proceed with asking them some really good questions about this. Remember to always ask them, how do they know that it went where they went, and have them use mathematical language that's talking about distances. So now I'm going to ask a series of really good questions to get them thinking. So the questions might include things like, which two numbers up here are closest together mathematically? And of course ask, how do you know? I might ask them, how far away is 32 from 20? Now I'm not looking for 3 inches. I'm looking for the numerical value, that it's 12 units away. I might ask them, what number do we need to add to 70 to get to 100? How about this one? Which distance is greater, 8 to 20 or 20 to 32? And how do you know? And which number is less than 70 but greater than 20? Have a discussion about those greater than and less than words. Then I would remove some numbers, give out some other random numbers, and we'd start the process all over again. This sixth task is called Find the Middle. So this activity is going to help students identify that the halfway benchmark is an important skill. So we'll begin by placing the 0 and the 10 card. And I'm going to ask students to place a blank card at the halfway point. Once they place it, we'll have a discussion about the importance of the size of the interval, and then we'll make adjustments until we have decided that we have found the middle. Ask students what number belongs on this middle card, and have them have a discussion about that, and hopefully they're going to come up with that 5 belongs in the middle. So once we've done that, we're then going to start changing the endpoints. So now my number line is a 0 to 12 number line. I would ask them, what would I need to do with the middle card? Does it need to move? I'm hoping they're going to realize that the middle is always the middle. The card doesn't move, but the number value will. So I would now ask them what value goes on the card. I'm going to continue to challenge them. I'm not going to start at 0 now. Now maybe my starting point is 20 and my ending point is 100. Does the middle of 20 to 100 change? Does this middle benchmark change? No, but the value changes. So our discussion will be focused on what is the value of the number that comes exactly halfway between 20 and 100. The richness of this activity is going to be the discussion of how they came to find what the middle was. Some students may recognize that there's a spread of 80, and so there has to be 40 on this side and 40 on this side. So 20 plus 40 is 60, or 100 minus 40 is also 60. So the discussion is going to be the powerful piece here. Then I may pose a question and ask, where does this fall? Will this fall to the left of center or to the right of center? And how do you know? This will further support the idea that they recognize that the center is 60 and that this should fall here. So if they place in the middle, we're going to have a discussion. Is 70 halfway between 60 and 100? I'm hoping that they reason that no, 80 is halfway between. So they recognize that they would have to adjust the 70 to be closer to center than to the 100th. All right, our activity number 7 is called Definitely Not. So you'll notice that I began this activity by placing a 0 and a 5/10 decimal value on the number line. You can use any numbers you want depending upon the level that your students need. So consider the 0 to the 5/10. I'm going to place a blank card. I want you to think in your mind what this card could definitely not be. It is important that we need to develop the skill of having students understand non-examples, and that's what this activity will do. It will help us to build that capacity with students for them to be able to find non-examples by finishing the statement. The blank card cannot be the number because, so think about what you might say. I might have a student say, the blank card cannot be 6/10 because 6/10 would come after 5/10. Someone who's taken a little bit more of a risk might say, the blank card cannot be 3/10 because 3/10 would be closer to 5/10 than it is to 0, and the blank card is closer to 0. Challenge your students to take bigger and bigger risks by getting a number that would be closer and closer to what it could be, but still stating what it can't be. This activity was called Definitely Not.
Task 8 is called What If? You're going to begin by displaying a start point. I've chosen the start point of 2. Then you're going to display 2 blank cards randomly placed to the number line, to the right of the given value. Ask, what if the last card was 10? What could the middle card be? Have a discussion with the students about their ideas. Then ask, what if the middle card was 10 and not the last card? What could the last card then be? Be sure to help your students consider reasonable answers. It would be unreasonable, for example, to say the last card is 100 when considering the interval between 2 and 10. Intermediate teachers, remember to consider decimals and fractions to raise the level of this activity. Task 9 is called What's the Pattern? You will be giving selected students number cards that have a mathematical pattern, but don't tell them there's a pattern at this time. Call on a student that's holding one of the cards to read the value on his or her card. Carly?
32.
Tell the students we're trying to find the beginning endpoint. Does anyone have a value that's smaller than 32?
12.
Does anyone have a value that's smaller than 12?
2.
Does anyone have a value that's smaller than 2? Okay, so once we find the smallest value, we will use that as our beginning endpoint. Have the student place that to the left of the number line. Repeat this process to find out who's holding the greatest value. Does anyone have a number that's greater than 2?
32.
Does anyone have a number that's greater than 32?
52.
Does anyone have a number that's greater than 52? Okay, 52. Come on up and place your number at our endpoint. Ask the remaining students who have cards to place their numbers where they belong on the number line, and remind them to be mindful of appropriate distances from their neighboring numbers. With your students, adjust the spacing as needed. Once we've agreed on the spacing, ask the students, what do you notice? Allow for every observation with the hope that someone will notice that the numbers are equally spaced in value, which means they should be equally spaced on the number line. Now we're going to be talking about task number 10, equivalent values. Begin by giving student fraction cards that contain like denominators. I'm going to be using thirds. Ask those students to place the cards on the number line. Perhaps you could use the process we just used in the last activity, task 9, what's the pattern? So the students will come up and place their fraction cards on the number line. Once you have agreed that with your students on the proper placement of the fractions and discussed how they know, show students the card with the whole number 1 on it. Ask the students, where does this number belong? And be sure to give plenty of think time. Listen to the students' ideas. Once you've unraveled the mystery that 1 is equivalent to 3/3, place the 1 card over the 3/3 card on the number line. Now, show the card with the whole number 0. Ask the students, where does this number belong on the number line? Again, give think time and discuss placement. Be sure to ask, how do you know? And finally, I will show the whole number 2. Ask your students, where does this number belong on the number line? Once the students identify that the whole number 2 is equivalent to 6/3, place the 2 over the 6/3 on the number line. As you can see, this is a great activity to show equivalence between fractions and whole numbers using the number line, including fractions beyond the value of 1. Now we have task 11, place the fraction. As you can see, I've displayed the numbers 3, 4, 5, and 6 on the number line. Show the students the fraction card 5 3/4. Ask the students, where does this belong on the number line? Without saying whether they are correct or not, have them place a blank card in the location to mark their idea and ask them to justify their location. You may have 1, 2, or even 3 different responses. After discussion, and the students have identified that 5 3/4 belongs between 5 and 6, push them further by asking, does it belong closer to the 5? Does it belong closer to the 6? Or does it belong in the middle of the 2 numbers? And be sure to ask them, how do you know? Once the students have correctly identified and explained that 5 3/4 is closer to the 6, place the 5 3/4 card on the number line. What a great activity to show that whole numbers and fractions live together on a number line.
This last task, task number 12, is going to round out our dozen tasks. This one's called Create Your Own. You're going to begin by displaying a number line with 2 given endpoints. You're then going to ask students to create a number and write it on a Post-it note that would fall between the 2 given endpoints. Then ask students to come up and post their Post-it note on the number line using a clothespin. Now remember, they have to consider the interval. You might decide to leave it up for the whole day and have students just come and view it and discuss it throughout the day. And then later in the day or the next day, ask students to justify or critique one of the Post-it notes and its location on the number line. Well, thanks for watching. If you found this to be useful, please tell a colleague about this video. It just might spark some really exciting conversations about using the number line in your classroom. We are certain that you will begin to find dozens more ways to use a number line for instruction, and not just as decoration in your math classroom.